Welcome back. In this video, I'm continuing daily Leetcode problem, and for today, that's 840 magic squares in a grid. So, a 3 times 3 magic grid is a 3 times 3 grid filled with distinct numbers from 1 to 9, such that each row, column, and both diagonals all have the same sum. Given a row and column grid of integers, how many 3 times 3 continuous magic square subgrids are there not? While a magic square can only contain numbers from 1 to 9, grid may contain numbers up to 15. Okay, so it has to have the same sum. It has to have all distinct numbers, and there are 1 to 9. So it has 9, so 1 to 9 strictly. And if we also, if we calculate, so what's 1 plus 2 plus 3 plus so on till 9, we actually get that's 45. So if it's 45, if each is the same, that means each is 15. So this is 15, this is 15, this is 15, this, and all grids. So that's essentially the idea of this approach. Okay, yeah, so in this example, we need to get 15 here. So 4 plus 5 plus 6, 15. Also here and here and here, and so on. So let's try to code this up. Okay, so let me check first the constraints. Rows is grid length, column is grid of file length, row and columns are between 1 and 10. Okay, but we need 3 times 3, so we'll check this also. And grid last value is 15. Okay, so rows is equal to length of grid, and columns is equal to length of grid 0. We know it will always have one element, so this will work. If rows is less than 3 or false is less than 3, we return 0. And now let's get to the main part. So what do we need to check? For, let's call it row start, in range it will be rows minus 2. So the last row start element, we will not consider last 2 rows, because we need to have 3 by 3 grid to start in that row. So we need 2 rows under also. Okay, so for row and for column start in range equals -2, so the same thing. We need to check our output. Output is 0. Okay, I will make a function that will try to find magic grid. So the magic grid with inputs row start and column start. So it will return 1 or 0 depending if the starting position, row and column can, from that starting position, we can build a magic grid size 3 by 3. So output will be plus equal what magic grid returns. So magic grid of raw start and C start. Okay, and in the end we just return output. Okay, so we have a starting point of this possibly magic grid. What do we need to do? We need to check if all elements are distinct and one to 9. So for this part, we can use maybe counter or okay, let's make like this. So for I in range, so 0, 1, and 2, so it needs to be in range 3. First we're gonna I'm gonna check this part later. So check columns and rows. So how do we check one row? One row is grid of, so row and this is one row, so C till C plus 3, excuse me. So this is one row, so between C from the row R, element C to C plus 3, and this will be for each row. So we need to see if sum is not equal to 15. So if this is true, we need to return 0. And for the call sum, let's call it like this. Call sum is equal to, so okay, so to sum we have to do like this, so plus I 3 times. So this will sum, let's say this is the beginning, it will sum this one, so yeah, this one, row plus 1 and row plus 2, and for I0, I1, I3, I2. Okay, and if call sum is not equal 15, we return 0. And now check distinct. Okay, so to check distinct, I could also this approach, how could I do it? Okay, I can like magic grid is equal to this. This will work. So I will append all rows. So each row and the values in possible magic grid, I will append to magic grid. And here we're gonna check if all elements are distinct and between 1 and 9. So we can make so occurrences, counter of magic grid. This is both of one space, the magic grid and the counter. So occurrences is counter of magic grid. Okay. And for key in occurrences, maybe I spelled it wrong. Should be like this, but never mind. I'll call it OC. So if key is not nine, turn 0, and if length of OC is not equal 9, return 0. This means that we have same elements, so maybe number 2 is like 3 times, so we need to have 9 distinct ones. And if everything is okay, we return 1. Okay, should be good. Let's try to run it. Like this. If key is okay, not sure why this doesn't work, maybe not. Okay. We haven't checked diagonals, so that part also. Diagonal 1, let's say, is, we'll take this part, so grid of RC, R plus 1, C plus 1, R plus 2, C plus 2. And the same for diagonal, not same, but similar, so C plus 2. This is the same, and this is 0. So this is the last element, this one, and this one. Yeah. So if diagonal 1 is not equal 15, or diagonal 2 not equal 15, we return 0. Let's try again. Okay. And it's accepted. For the time and space complexity, so we are calling this magic grid for, so each for the size of rows times calls minus 2. So should be rows times calls if we remove the constants. And here we do like 3 times this. So yeah, this should be of 1. Everything for key. This is of 1 also because we have only 9 elements at most. So yeah, should be rows times columns. Let's see if we can see. Yeah, n times m. And for the space complexity, should be off 1, but I'm not sure. Yeah, it's off 1. Okay, I hope this made sense. Thank you for following in this one, and see you in the next one.